All right. So momentum is mass times velocity. There we go. So the symbol P is for momentum. It's mass times velocity. Mass is always kilograms. Velocity is meters per second. Velocity is a vector. It is speed with direction. If it's positive, it's moving to the right. If it's negative, it's moving to the left of your paper. All right. And the most important principles, the law, is the conservation of momentum. So if you think of this dude who broke his nose, right? Now, at the start, nothing's moving. So momentum of anything, and we're talking about the gun and the bullet really, but anything is m times v. V is nothing. So there's no momentum. So at the start, there's zero momentum. And what the conservation of momentum says, wherever it's at the start, it must be at the end. Right? So if it's zero at the start, it has to be zero at the end. All right, so let's play it. Let's see what happens. So I'm going to pretend, right, this dude's bullet is there, and we'll write a few things down about this. So a few things I'm going to write down is the mass of the bullet is 0.1 kilograms. I'm going to pick some nice numbers. The mass of the gun is 10 kilograms. Let's put equals there. All right. I'm going to assume all these things. Well, we know these things. This before he's firing, it doesn't matter what you try to calculate, the velocity is zero. Okay. So what happens at the end? Well, at the end, the velocity of the bullet, is 1,000 meters per second. Okay. All right. So we know the velocity of the bullet now. So now we can work out at the end what's going on. We can use mass times velocity. We can work out the momentum. So the momentum, so at the end, the momentum of the bullet is P equals M times V. P equals M, 0.1 kilograms, times velocity, 1,000. So the momentum, P, is equal to 100. That was 0.1 kilograms. Kilograms times meters per second are your units, which is 100 kilogram meters per second. But now I've got a problem. The conservation momentum says it must be zero. That isn't zero. That's 100. The momentum of the bullet is 100, but everything has to be zero. If the bullet is moving forward with a momentum of 100 kilograms per meter per second, it is moving to the right of your paper. Meaning the gun must move back with exactly the same momentum, but of minus 100, because it adds up to zero. All right, so what is the momentum of the gun? Well, the momentum of the gun must be equal and opposite. It has to equal zero, so it must be minus 100 kilograms meters per second. Okay, so now that we know all that, I can ask a really cool question. How fast was the gun going when it broke his nose? How fast, or what was the velocity of the gun? Okay, so now we know its momentum. So we know the momentum of the gun is minus 100. And that will be equal to its mass multiplied by its velocity. Okay? Well, we know its mass because I wrote it there. Its mass was 10 kilograms. So we got minus 100 equals 10 times velocity. I don't want 10v, I just want 1. So I'm going to divide both sides by 10. Or however your maths teacher's taught you, I'm going to divide this side by 10. I'm going to divide this side by 10. Okay. So what we end up with is this really cool calculation. Minus 10 equals velocity. Right? So I want you to remember velocity is a vector, meters per second. Minus 10 means it is moving to the left. So when that gun hits his nose and breaks it, it is moving at a velocity of 10 meters per second to your left. What a muppet. Broke his nose on YouTube. It's absolutely hilarious. So that's it. So what you're going to do today, you have a set of questions over here. All right. And these are the questions you've got to finish off. All right. So let me stop recording.